Hello everyone and welcome back. In today's class, first of all, we will discuss about the area vector. So here we have two cases everyone. First of all, we will find area vector for the open surface. So here you can see it in this picture. We have an open surface, like I have this disk, and disk is what it is, the open surface, correct? So if I'm considering upward is positive, then downward will be what? It will be negative. And if I'm considering downward is positive, then upward will be negative everyone. Remember this thing. So here we have an open surface and I'm considering upward is positive. Then downward is what? It is negative everyone. And keep this thing in your mind. Area is the vector quantity. Alright. And for the open surface, how we can find out direction of area vector? This thing you know right now. If suppose in the question we know that direction of length and direction of width also, both things is given in the vector form. Alright, and we want area vector. So what we can do it? Just do it cross product between length and width. So if in the question we have length in the vector form, width we have in the vector form, and we want area vector. So what we will do it? We will do it here cross product between N, L and W, and then you will get area vector everyone. I hope this thing is clear how we can find out area vector for the open surface. So note down everyone. Let's see it next everyone. Area vector for the closed surface. So now we will find for the closed surface everyone. So for a closed surface, the area vector direction is always normal to the surface and directed outward. So here we have one sphere. You can see it in this picture. We have one spherical surface, and let's suppose at that point we want a direction of area vector. So what we can do it here, how we will draw direction of area vector? We will draw here one arrow. We will put, correct, tail of the arrow at the center of the sphere, and here we have head of the arrow, correct? So you can see it here. Right now this vector is going radially outward direction and it is passing from that point also where we want direction of area vector. So like this we can represent direction of area vector everyone. Same thing if I want direction of area vector at this point. So again we will draw here one vector radially outward direction, and this is representing direction of area vector. Now in the second case, what is happening here? We have one cube everyone, and here if you want to make area vector for this surface, so what I have to do it? We know that area vector is what? It is always normal to the surface. So this is the surface everyone. Direction of area vector is what? Normal to the surface. So for this surface, this is the area vector. For this surface, direction of area vector is this everyone. And for this surface, this is the direction of area vector. So I hope this thing is clear to everyone how we can write area vector direction. So note down this one also everyone. Let's see it next topic everyone, electric flux. So what is the definition of electric flux? It is the measure of net electric line of forces crossing the surface normal to it. How many number of field lines passing normally through the surface? This measurement we are doing with the help of electric flux. So I hope this thing is clear. What is the sense of electric flux? Correct. Like I have this surface everyone, and how many number of field lines passing normally through the surface? This measurement we are doing with the help of electric flux, correct? And how we can write down this electric flux mathematically everyone? So mathematical formula we have E dot A. When electric field line is passing normally through the surface, then it is the electric flux. When magnetic field line is passing through the surface, then it is the magnetic flux. If air is passing from the surface, then it is air flux everyone. Alright, so now we are talking about the electric flux everyone. So here we have electric field. So how we can write down mathematically? Phi equal to E dot A. This is a mathematical formula. E is the electric field and A is the area vector, correct? And if we will remove dot product sign, then we will get cos theta, where theta is what? Is the angle between electric field and area vector. Alright, let's suppose here we have one surface everyone which is present in this electric field, So here we have one surface, and the surface is present in this electric field. Correct? And direction of area vector is perpendicular to the surface, everyone. So this is the direction of area vector. And let's suppose this angle is theta, everyone. So this is direction of electric field, and area vector, we know that it is perpendicular to the surface. So this is the area vector, and angle between electric field and area vector is what? It is theta. Correct? So this is the angle between this electric field and area vector. All right, now the next thing is what, everyone? If suppose we have one surface, like I have this, and field lines is passing parallel to the surface, not a perpendicular right now. Like this is the surface and these are field lines, and now it is passing like this. So if it is passing like this, so here field lines is parallel to the surface, not a perpendicular to the surface. Correct? So in this case, field line is not crossing the surface. That's why flux should be what? It should be 0. Correct? So see it, everyone. Let's suppose here we have one surface. All right, and field line is passing parallel to the surface like this. We have one disk, and we can see it here in this picture. Field line is right now parallel to the surface. It is not passing normally to the surface. So theoretically, if we will think here, so flux is what? It is 0. Flux is 0, everyone, because field line is parallel to the surface. But and same thing if you want mathematically. So formula is what? Mathematically, if you will see it, everyone, phi equal to E dot A. All right, remove this dot product sign, then we have cos theta, and theta is what? Is the angle between electric field and area vector. So this is the direction of electric field, and if I will make here area vector, so it is normal to the surface. So this is the direction of area vector, everyone, normal to the surface, and we can see it here, angle between electric field and area vector is what? It is 90 degree. So when theta is 90 degree, then cos 90 is 0, then you can see it here, what we will get? Cos 90 is 0. Flux, what we are getting? We are getting 0. So if we will do it mathematically, or if we will think theoretically, from both this, correct? From both we are getting same result. So if you will think theoretically, or if you will do it mathematically, from both you are getting same result. So I hope this thing is clear, everyone. What is the electric flux? What is the sense of this electric flux, and how we can find out electric flux mathematically? Let's see it one question, everyone, on the basis of this concept. So here we have question: a square surface of side L is placed in a uniform electric field E, acting along the same plane at an angle theta with the horizontal side of the square. The electric flux linked to the surface in unit of volt meter is what? So here we want electric flux, everyone. This is the question. So if you will see this picture, everyone, so what is happening here in this picture? Let's suppose this is surface, everyone. All right, this is surface, everyone, and field line is parallel to the surface. It is not normal to the surface. All right, so in this case, what will happen? We know that flux formula is what? It is E A cos theta. All right, so E A is A, everyone, and what is the theta here? Correct. See, this theta is different. Here we want angle between electric field and area vector. So no need to be confused here. All right, this theta is what? I am representing with the phi, everyone, because you are getting confused here with the theta and phi. Correct. We want a phi. Phi is what? Is the angle between electric field and area vector. And direction of area vector is what? It is perpendicular to the surface. Correct. So this is the surface, everyone, and area vector is perpendicular to the surface, and this is the direction of electric field. So between this both we have angle 90 degree. So here phi value is what? It is the 90 degree, and cos 90 we know that it is 0. So answer is 0. And directly you can think it, everyone. Here field line is passing parallel to the surface. It is not passing normally. That's why flux is 0. So the correct answer is what? It is option number D. Answer is 0, everyone. Note down. Let's see next question, everyone. What is the net electric flux through the cylinder of length L and radius R as shown in the figure? So here we have one cylinder. You can see it in this picture, and this cylinder is present inside this constant electric field. This electric field is constant here, everyone. This thing is important. It is constant, correct? So we want here, what is the net electric flux passing through this cylinder? So if you will imagine here, everyone, let's suppose this is cylinder, everyone. This is cylinder, correct? So what is happening? From one side, field line is entering, all right, and from the other side it is exiting. So entering flux equal to exiting flux, all right. And what is happening on this curved path, everyone? Here field line is parallel to the surface, all right. So in this case, flux passing from this curved part is what? It is a 0. Only flux is entering from the here, from this circular part, and it is exiting from the other circular path. So here E is constant, everyone, and area of this side and area of this side is same, correct? Area of this side and area of this side is same. So area is same, electric field is same, so entering flux equal to the exiting flux. So from the one side, flux is entering, everyone, and from another side it will exit. So entering flux is equal to exiting flux. That's why net flux passing from this surface is what? It is 0. All right, and from the curved path, flux is not passing because field line is parallel to the curve. That's why it is happening. All right, and if suppose, see it, in this question we have cylinder, so we are getting 0 answers. The correct answer for this question is 0. If suppose we are putting any other shape, like I am putting this mouse in the electric field, in the uniform electric field, then what is the answer? Then again answer is 0. All right, if we are putting any object in the constant electric field, then answer is always 0, everyone. Keep this thing in your mind. Let's suppose here we have electric field, and this electric field is constant, and in this electric field if I will put one cone, everyone, so if I will put one cone in this electric field, the net flux pass from this cone will be what? It is again 0. So whatever shape object we will put in the uniform electric field, always answer is 0. If you will put one sphere, cone, or some random shape of object, correct, answer is 0. But if electric field is not constant, then answer can be different also, everyone. Then we need to calculate, because then entering flux and exiting flux can be different, because electric field is varying in that case. That's why it can be different, correct? So keep this thing in your mind. If the electric field is constant, then flux is always 0. If electric field is varying, then we have to calculate, then it can be different also. All right, note down, everyone. Let's see next question, everyone. If an electric field is given by 10I plus 3J plus 4K cap, then calculate electric flux through the surface of area 10 unit lying in YZ plane. So let's suppose this is x-axis, everyone. This is y. This is x. This is y, and this is z. So according to the question, our surface is present in YZ plane. Means it is present in this YZ plane, correct? So this is our surface, everyone. All right, and area is given. Area of the surface is what? It is 10 unit, everyone. So direction of area vector is this, everyone. This side we are considering positive, magnitude is 10, and direction is what, everyone? It is in positive x direction. It is towards the positive x direction. So if I will write area vector, so first we need magnitude, which is 10 here, and direction is present toward the positive x, so it is I cap, everyone. All right, so 10 I cap, this is the area vector, and electric field is already we have is 10I plus 3j plus 4k cap. All right, so electric field we have, it is this. Area vector we have, so flux can be written as what? It is E dot A. This is E dot A, correct? What is the E value, everyone? Value of E is 10I plus 3j plus 4k cap dot area vector, which is 10I. Now do it dot product, I with I, j with j. So 10I into 10, it is 100. So what is the flux here? It is 100 unit. Now check your option, then we are getting option number D, 100 unit. So I hope this question is clear how we can do it. All right, note down, everyone.